Good morning, sir.
Good morning, sir.
Good morning, sir.
Hello, good morning to all of you.
Good morning, sir.
Hello, good morning. Good
Yes, sir,
morning. Fellows are joining very slow, man.
Sir.
Okay, let them join. Let them join.
Salam alaikum.
The sound. Ayo, tap the person. Yedama. లేదు సెట్ అందుకని ఓకే 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 hello today I have a lot of task to say. My task is like we are actually revising inorganic 13th group and 14th group is the weekend portion. So in this portion, what should I study? First, I want to ascertain. In all, it has 20 pages. So today is Wednesday. You should study 10 pages from NCERT. Reading 10 pages is not a joke. It requires 2.5 hours time. Thursday, you should study next 10 pages from the same NCERT. It takes another 2.5 hours time. After studying these 20 pages, I am going to send you one booklet that contains 45 questions. You should practice all the 45 questions, each question 3 times. Also, there is a link called exemplar problems. Our plan is Friday you do 20 questions from this book, and in exemplar problems you do 10 questions. Saturday you do 25 questions from this book, and in exemplar problems you do next 10. And Sunday morning you revise 45 questions, go to exam. This is the plan. Now, what you have to study? The overall idea I want to give. The topic you should study is P block elements. Okay, sir? Yep. This is the lesson. I think you have this lesson. Do you have this lesson or should I?
We have.
Hello?
We have,
Yes, sir. Now, in this lesson, I want to, now what I will do? I want to tell you the summary. Yes. This is a lesson summary. The P block of the periodic table is unique in the sense that the P block contain all varieties of elements like metals, metalloids, and non-metals. P block is there in the right extreme of periodic table containing 13, 14, 15, 16, 17, and 18 groups. 13th group elements are called boron aluminum family. What are those elements? Boron,
aluminum, gallium,
boron,
indium, thallium.
yeah. 14th group is carbon, silicon, germanium, tin, lead. Notice the boron of 13th group, the carbon of 14th group, and the nitrogen of 15th group, oxygen of 16th group, fluorine of 17th group, neon of 18th group. They are all in second period. The second period elements have only 2 electrons inside. Outside, if you take boron, 1s2, 2s2, 2p1. Outside 3, inside 2. If you look at aluminum, outside 3, but inside 8. If you look at gallium, outside 3, but inside 18. The difference in the core electronic configuration brings a lot of difference between these properties of the 13th group elements. Also, boron, the first element, behaves differently from the rest of 13th group elements. Carbon, the first element, behaves differently from the rest of the 14th group elements. Nitrogen, the first element of 15th group, behaves differently from the rest of the group elements, so on. Why the first element is different from the rest? Because it has small atomic size, high electronegativity, absence of empty d orbitals, and ability to make p-pi bonds. Always the second period elements can make p-pi double bond. For example, nitrogen can make n double bond O. That is a p-pi bond. Carbon can make C double bond O in CO2. p-pi bond. The silicon, next element to carbon, is not able to make SiO double bond. Carbon is making C double bond O, and making CO2. But next element to carbon, that is silicon, is not able to make a double bond like carbon. Means the second period elements have ability to make p-pi bonds. Third period elements don't make p-pi bonds, but they can make a d-pi bonds. Therefore, that brings a lot of difference in their chemistry. The first paragraph talks about the ideas like this. The 13th group elements, they have 3 electrons in outer level, so they can show +3 oxidation state. However, boron, aluminum, gallium, indium, they all can show +3. If you come to thallium, last element, it cannot show +3. Why? In thallium, the outer 6s electrons do not participate in bonding easily due to inert pair effect. Notice that aluminum readily loses 3 electrons to give +3. Thallium never likes to lose 3 electrons. It won't give +3. If you forcefully make Tl +3, it urgently takes 2 electrons from others to become +1. It means aluminum has a tendency to lose electron. Thallium is not having such tendency. Fellows which have tendency to lose electrons have negative electrode potentials. Fellows which have a tendency to gain electrons have positive electrode potentials. In the 13th group, only element that have positive electrode potential is thallium. Aluminum has largely negative potential, indicate aluminum is the best loser of electron. Loser of electron is called?
Metal.
It is a metal, and also it is a reducing agent. Okay? Right. The size of the atoms matter a lot. Notice second period elements can make maximum 4 bonds, whether it is boron, whether it is carbon, whether it is nitrogen, whether it is oxygen, whether it is fluorine. Maximum they can make 4 bonds because second period elements have 2s, 2px, 2py, 2pz, only 4 orbitals. Carbon can make maximum CCl4. But silicon can make SiF6 2- ions. Silicon is making 6 bonds with 6 Fs. Why silicon is able to make 6 bonds means silicon has empty d orbitals which can accept electron pairs. So silicon valency can go beyond 4. You understand? Carbon can make 4 bonds because it has 4 electrons in the outer level. Silicon can make 4 bonds because silicon also has 4 electrons. More than 4 silicon can make 6 bonds. Why 6? Because it has empty d orbitals. Okay. Now there is a question. Silicon make SiF6 2 minus ions. Carbon is not making CF6 2 minus ions. Why like that? Carbon has no empty d orbitals. Carbon valency cannot be more than 4. Carbon cannot make CF6 2 minus ions. Silicon is making SiF6 2 minus ions, hexafluorosilicate ions. Sir, if it is making SiF6 2 minus ions, can it make SiCl6 2 minus ions? Carbon makes only CF4, Khel khatam. Silicon make SiF4, if required SiF6 2 minus ions. So the valency of carbon in this compound is 4. Silicon valency is 4. Here silicon valency is 6. The valence of silicon is increasing because it has empty. No, my problem is silicon is making hexafluorosilicate ion. Can it make hexachlorosilicate ion?
No, sir, because bulky chloro groups cannot be accommodated around
So
silicon.
that is a concept. I think you learned this. That's very good. I'm so pleased. So like that, you should study analytically the lesson. In the lesson, you should read the summary first. Okay. Okay. After looking at the summary, you get an idea what is this topic talking about. Why boron aluminum family members make electron deficient molecules? Because they have 3 electrons. Even if they make 3 bonds, they get only 6 electrons. Still, they require 2 more to get octet. Hence, AlCl3, BCl3, B2H6, all these are electron deficient. They have dozens of electrons called Lewis acids. In B2H6, the specialty is you have special bonds called banana bonds or 3 center to electron bonds. Students should know what is borax, Na2B4O710H2O. Borax can be actually written as Na2 B4O5OH 4 times 8H2O. Borax is a very important chemical. It is used in the identification of different ions. Borax is used to make glass and certain antifungal ointments. In carbon silicon family, most important is the allotropic forms of carbon like diamond, graphite, buckminsterful. In what way they are different? Diamond is the hardest known material. Sir, diamond is the hardest material. If you slip the diamond from your hand, when it falls on the ground, will it break or not?
No, sir, it will not break.
No, sir.
If you slip diamond from your hand, it will break into 100 pieces. Stupid fellows. Diamond is hard, but it cannot withstand shock. It is brittle. Diamond powder is available. Some people put it in rings. Diamond can be ground. Diamond can break. Diamond cannot withstand shock. In fact, if you leave graphite, it may not break because graphite is somewhat soft. It can withstand shock. Diamond can never withstand shock, though diamond is hardest. So if you take a diamond and just scratch on a wall, even if it is iron wall, it can cut. But if you slip the diamond from your hand, it will break. See, that term hardness is different from brittleness. Diamond is hard as well as brittle. In diamond, every carbon is sp3 hybridized, making 4 bonds. No unpaired electrons, so diamond is a non-conductor of electricity. Diamond is chemically inert. But thermodynamically, diamond and graphite, which is stable?
Graphite.
thermodynamically graphite is stable. It means thermodynamically diamond is not so stable. If you expose a diamond to heat radiation, will it catch fire? You bring a magnifying lens, focus the light on diamond. Will it burn?
No, sir.
It will burn very brilliantly. Don't do that. You can, cost of diamond is in the order of crores. You bring a good magnifying lens and focus. Within half an hour, it catches fire. Please don't do that, okay?
Yes, sir.
If you focus a light on graphite, it won't burn so easily. It is difficult to burn a graphite, but you can burn a diamond. Okay? Diamonds are, there are so many facts about diamonds. People think it won't break.
Hello. Hello. Hello.
Hello? Hello? Are we there?
Yes,
Hello?
sir.
Hello?
Yes, sir.
Is there any break in between?
No, sir. No.
I was shouting and I was wondering whether you are hearing me. Okay, sir. I was wondering about what
So you were
about I was
telling
telling.
about diamond.
So there are so many facts about diamond. Please realize, diamond is a non-conductor of electricity. Diamond is brittle. Diamond is chemically inert, but diamond is combustible. And diamonds are very expensive, used to make cutting tools and also space windows. And in optical instruments, diamonds are used. Apart from the usage as a jewelry, there are many stories associated with the diamonds. It's
Diamond
said
is
that
used to cut the glass, no, sir.
diamond is used to cut not only glass, to cut anything you can use diamond. You can make a hole to big mountain using diamond. But there are so many stories related to diamond. Some people think they bring misery. Okay. So anyway, so leaving that aside, in the 14th group, I should know what is diamond, what is graphite, which has a layer-like structure, sp2 hybridized carbon. Each carbon of graphite has one unpaired electron. It is a conductor of current. And between the layers, CC distance is around 340 picometers. It is very weakly attracted. Therefore, one layer of graphite can slide over the other layer. Hence, graphite is soft. Graphite crucibles are used to withstand high temperatures. Graphite is also used as a conductor of electricity to make some batteries. The third variant is Buckminster fullerene, which has a buckyball like a football like structure. It has 5-membered rings and 6-membered rings. Carbons are sp2 hybridized. It is said to be aromatic. In Buckminster fullerene, carbons of 5-membered ring must be linked to carbon of 6-membered ring. Whereas carbon in 6-membered ring has a flexibility. It can be linked either to 6-membered ring or to 5-membered ring. So, Buckminster fullerene is third variant of crystalline allotropes of carbon. Essentially, allotropes are different physical forms of the same element. But crystalline allotropes have crystalline structure. Amorphous allotropes, they don't have crystalline structure. Animal charcoal, lamp black, etc. Therefore, understand, different physical forms of carbon, silicon, are allotropes to be studied. In the 14th group, you need to study about the silicones. Normally, they are asking a question on silicones. Silicones are polymeric materials. They are elastomers. They have wonderful uses. Also, you should study in 14th group what is water gas, what is water gas or synthetic gas, syngas, and what are its uses, carbon monoxide, hydrogen. What is your producer gas? If you pass steam over hot carbon, you get water gas. Instead of passing steam, if you pass air over hot carbon, you get a producer gas. Either of these are used as fuels. So in 14th group, you are going to study about these gases, silicones, and also you will study about, most importantly, zeolites. To quickly say, silicon exists in nature in the combined form with oxygen. Each silicon makes generally 4 bonds with oxygen. Whenever oxygen makes only 1 bond, it gets minus charge. Compounds which have SiO4 4 minus ions are called as orthosilicates. There are many types of rocks in Earth. For example, Na4A SiO4, Ca2 SiO4, NaAl SiO4. So, why you require NaAl? Because SiO4 has 4 minus charge. The oxygens all are linked to only one silicon. Nobody is sharing because it has 4 minus charge. You needed 3 plus 1, 4 positive charges. Even in Cf2, there are plus 4 charges. Plus 4 charges. The compounds which have SiO4 minus unit separately is called orthosilicate. Sometimes what happens is, in a natural rock, one oxygen is shared between 2 silicate units. Then this is called pyrosilicate. Pyrosilicate has Si2O7, 6 minus charge. Therefore, in pyrosilicates, there is SiO-Si linkage. Pyrosilicates are a type of rocks formed when 2 silica shared 1 common oxygen. We say 1 corner is shared. And write like this. Only 1 oxygen is shared. 1 oxygen is shared is called pyrosilicate. Sometimes 2 oxygens are shared. If 2 oxygens are shared, it has a formula Si2O6, 4 minus. Can you see it, sir? Whenever oxygen is making 1 bond, it gets minus charge. Whenever oxygen is making 2 bonds, no charge. So Si2O6, 4 minus. It can also be written as SiO3, 2 minus. It is called sheet silicate or chain silicate. What is the name, sir? I said it is called chain silicate or ring silicate. Chain silicate or ring silicate. Very rarely, sir, 3 oxygens are shared. When 3 oxygens are shared, each silicon is bonded to a free oxygen. Si2O5, 2 minus. This is called as sheet silicate. No corner is shared is called orthosilicate. 1 corner is shared is called pyrosilicate. 2 corners are shared is called chain silicate or ring silicate. And if 3 oxygens are shared, it is called sheet silicate. If all the 4 corners are shared, it has a formula like Si2O4 or Si4. The SiO2 where there is all corner sharing is called as three-dimensional network solid or medicine. So silicate exists in 4 different forms. You should read the NCERT to be familiar with 4 different forms. That is a note on silicates. In this family, sometimes they are asking, what is a question like zeolite? In SiO4, you know, silicon is +4, each oxygen is -4. You know that? Yes, sir? Do you know that?
Yes, sir.
Sometimes you can have, say, 5 silicons, 10 oxygens. It is a silicate. In the silicate, by chance, one silicon is missing. In this Si4 O10, how many silicons are missing, sir? How many are missing? It is Si4O10, it is Si4O10. One silicon is missing. To accompany that missing one, you put last end on a call. Sir, if you are replacing silicon with aluminum, then it will be AlSi4O10. If you carefully look at in Si5O10, 5 silicons make +10 charge. And all the O10 +20 charge, all the O10 make -20 charge. Can you see it, sir? Each silicon is +4, 5 4s are 20. Each oxygen is -2, 10 2s are 20. Notice, in the world, there are as many boys as many girls are there. Do you agree? Hello? Hello?
Yes, sir.
So in the world, there will be as many positive charges as many negative charges are there. Now here you are missing one silicon. When you are missing one silicon, one +4 charge is missing. To neutralize the +4 charge, you have kept one aluminum and also one sodium. Suppose if you remove 2 silicons, how many aluminums I should put, sir?
Two aluminum and 2 sodium.
Instead, I can also take 1 calcium, 2 aluminum, and can I do like that also?
Yes.
Now that is called calcium aluminosilicate. It is called sodium aluminosilicate. The sodium aluminosilicates are called zeolites. Zeolites are interesting compounds which are used to remove hardness of water. A zeolite is formed when one of the silicon is replaced by aluminum, only aluminum, not by aluminum oxide. And zeolites have interesting structures. Depending on the holes a zeolite has, the zeolite can catalyze conversion of alcohol into petrol. That zeolite which converts alcohol into petrol is called ZSM5. So question, what is zeolite? Sodium aluminosilicate. What is the use of zeolite? It is used to remove hardness of water as cation exchange resin or anion exchange resin. What is the other uses of ZSM5? It is used to convert
Alcohol
alcohol
to
into
gasoline.
gasoline. So you have to read all the lessons, sir, 10 pages, read the lesson, do the assignment. If you want, I will share it. And then that's the inorganic part you should do. You have to read the lesson with patience. When you are reading the lessons, sir, you come across tables. I will show you at that. Now there is a question, sir, should I have to by heart the table? No need to by heart the table, but see the trend. Atomic number down the group increasing. Mass number down the group increasing. The atomic radius down the group increasing. The ionization enthalpy, it is a bit irregular. The electron gain enthalpy. Second element has lowest electron. Can you see the values, sir? All the trends you should learn, sir. At least you should see the order in which they are distributed. Similarly, in 30th group, you can see the trend. My system is hanging. So this is the lesson you have to read and ask me doubts. You have to do it in 3 ways. What is borax? Na2B4O710H2O. What happens when borax is heated? When it is heated, it loses water to become sodium metaborate. What happens on further heating? On further heating, it becomes sodium borate and B2O3 mixture. What is the use of borax? All this you have to learn. Already I have explained this lesson long back to you. So read the lesson, post the doubts if any. Okay, sir? This table should I have to learn? I have to learn. Everything I have to learn in the NCERT. Inorganic only NCERT is enough. Okay? I am suggesting you 3 sources. NCERT book, exemplar problems, and one material I will share like this. If you do the 45 questions from this material, that's enough. A model question. Look at this question, please. 45. Hello? Are you looking at the question? Which of the following statement about
Sir,
the
we are
chelate is
unable to
false?
see the screens.
You kept quiet so far. Nothing looks. Yeah. I didn't answer to 45th question. ఆవిరి పెట్టుకోవచ్చు ప్లెయిన్ వాటర్ పెట్టుకోవచ్చు
D, sir.
D for donkey is wrong because a chelate contain is used in ion exchange resins to remove hardness of water. True. They have open structure which enables them to trap small molecules like alcohol and catalyze them to become petrol, gasoline. Chelates are aluminosilicates having 3-dimensional network is correct. Some of the SiO4 units are replaced by AlO4 5 minutes is wrong. In fact, some of the Si+4 are replaced by Al+3 ions. That's fact. Try to answer these 45 questions. This material I have shared with you. Okay, sir? Now, our task is doing organic. We are doing organic. We have closed this. Now we are going to organic. Did we start isomerism yesterday? Hello? Hello?
Sir, we started E, Z,
Yes,
I,
sir.
What did we do yesterday actually?
E and Z and E.
So we have already started the isomerism.
Yes, sir. Trans and
Now
cis.
look at this. In chain isomerism, butane C4H10 has 2 chain isomers. Can you write third isomer?
No, sir.
Can you write? No, not possible. Even if you try, you can't write. So butane has maximum 2 chain isomers. The branched isomer is called isobutane, which has lower boiling point. Always more is the number of branches, lesser is the boiling point. Okay, sir? Now my question is, if it is pentane, how many isomers you can write, sir? Chain isomers. Three. N-pentane, isopentane, neopentane. Neopentane has lowest boiling point. Now if it is hexane, how many isomers you can write? Hexane. Hexane. It is normal hexane. It is 2-methyl pentane. You can put the methyl group on second position and third position. Yes or no? If you put on second position methyl group, 2-methyl pentane. If you put methyl on third carbon, 3-methyl pentane. Can I put it on fourth carbon?
No, sir.
No, because if you try to put on fourth carbon, again it becomes 2-methyl pentane. So you can have normal hexane, 2-methyl pentane, and 3-methyl pentane. So these are 1, 2, 3. So far you have written 1, 2, 3, 3 isomers. Now you can cut one more carbon, put it on second carbon. Then it will become 2,2-dimethyl butane. Again, you can cut one more carbon, put it on third carbon here. Then it is called 2,3-dimethyl butane. Can you see it, sir? Hello? I am giving you a lot of time pausing. If I write all carbons in a single chain, this is hexane. Out of 6, I cut one carbon, put it on the second or third position. I get a structure like 2-methyl pentane or 3-methyl pentane. These 1, 2, 3 are chain isomers. Now, further, I can cut one more carbon in this case and put it on second carbon again. It will become 2,2-dimethyl butane. If I cut one more carbon, put on the third position, it can become 2,3-dimethyl butane. Can you see it, sir? Hello? Hello, can you see it or should we write? You should know that. Please read the content. Compounds which have different carbon chain lengths, those which have single chain and which have branched chain are called chain isomers. Butane can have 2 chain isomers and butane isobutane. Similarly, butene can have 2 chain isomers and butene and isobutene. Pentyne, if you take alkanes, you require minimum 4 carbons to have chain isomers. Alkene means you require 4 carbons to show chain isomers. It can be N-butane, isobutane. It can be N-butene, isobutene. If you take alkyne, if an alkyne has 4 carbons, it cannot show chain isomerism. For alkynes to show chain isomerism, you require 5 carbons. That is a very important point. Alkanes, how many carbons are required for chain isomerism? Sir, how many carbons are required for alkane for chain isomerism? Alkane. Hello? Are you there? Are you there? Hello?
वो देखो दोस्तों जरा ध्यान से कैसी मछली है ना?
Hello, can you hear me, sir? Hello?
Yes, sir.
Sir, the topic under discussion is
चलो
organic
उसके पीछे
chemistry.
चले।
लगता है उसे खाना मिल गया
I
है।
was wondering isomerism. Compounds which have same formula but differ in properties are sir. The isomers are hello, sir. I was talking about isomerism. Compounds which have same formula but different properties are isomers. If they differ in the structure itself, they are called structural isomers. Structural isomers can be chain isomers. In chain isomers, there is a difference in length of carbon chains. For example, N-butane, isobutane. N-butane has 4 carbons in one chain. Isobutane has 3 carbon chain with a side chain. If you are increasing number of side chains, the boiling point will drop. If I am looking at butane, it has only 2 chain isomers. If it is pentane, it has 3 chain isomers. If it is hexane, it has as many as 5 chain isomers. Can we write the 5 chain isomers of hexane means? Well, I can write like this. It is hexane. Now I will cut one carbon, put it here. When I am putting here, I have a scope to put it here also. It is called N-hexane. It is called 2-methylpentane or isohexane. It is called 3-methylpentane or isohexane. It is isohexane, it is also isohexane. So you need to specify IUPAC name 2-methylpentane, 3-methylpentane. Also I can have 4 carbons, I make a main chain and put a side chain like this, or I can put like this. It is called 2,2-dimethylbutane, 2,3-dimethylbutane. How many I wrote, sir? Please count the numbers. 1, 2, 3, 4, 5. How many chain isomers I wrote for C6H40? How many? How many? Hello? Okay. As the number of carbons is increasing, number of chain isomers also increase. For example, if I am having 7 carbons, I can write as many as 9 chain isomers, though it is challenging. If it has 8 carbons, it can have 18 chain isomers. If it has 9 carbons, it can have 35 chain isomers. If it has 10 carbons, it can have 75 chain isomers. Number of chain isomers drastically increase. But the isomer with more branches has lower boiling point. Another point, in alkenes also, to have chain isomerism, minimum you require 4 carbons. There can be 1 butene and 2 methylpropane. Both are having formula C4H8. They are chain isomers. Sir, if I write like this, 1 and 3 are not chain isomers. What is the relation between 1 and 3? Hello? Hello? What is the relation between 1 and 3? Are you there?
Position isomer.
Their
Yes,
position. It means alkenes can show chain isomerism and also position isomerism. Also, if I write like this, it also has formula C4H8, but it has no double bond, but it is a ring. The fourth compound is called cyclobutane. How 1 and 4 are related? One and 4 are called ring chain isomers. What is that? Ring
chain
chain.
isomers.
Ring chain isomers. Ring chain. Alkenes can show ring chain isomerism. Sir, with a formula C4H8, how many ring structures you can write? How many cycloalkanes are possible with C4H8? This is one. Anyone you can write? You can write this. What is this? It is cyclobutane. It is methyl cyclopropane. Can you see it? Hello? Hello? How many ring isomers you can write for C5H10? Try all of you. S. 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 Yes. How many I wrote, sir? How many? All they have one ring. Can you see it, sir? Hello. How many ring isomers are possible for C5H10 means 5. Can you see them? Cyclopentane, methyl cyclobutane, ethyl cyclopropane, 1,2-dimethyl cyclopropane, 1,1-dimethyl cyclopropane. So today we have seen chain isomers. We continue our lesson tomorrow. I think time is getting close. We continue tomorrow about isomerism, but your weekend syllabus is 13, 14 groups. You get 13 questions from there. NCRT you read today and tomorrow, 2.5 hours, 2.5 hours. Day after tomorrow, you read exemplar and 20 questions from the book that I shared. You want me to share that book again? Hello?
Sir.
Should I share the book again? No need.
No, sir, no need of that book.
Okay, do that book and I wish you good luck. We continue tomorrow. Now the time is up. My next batch is waiting.